Okay, hi guys. So in this lecture, we'll be discussing on Gay-Lussac's law. Okay, so first let me write down the heading first. Gay-Lussac's law, which states that at constant volume, pressure exerted by gas is directly proportional to the temperature of gas. Okay, or we can say that P is directly proportional to T. Okay, so this implies P is equals to KT. Okay, so when K equals to NR by V. Okay, so let's discuss the graphs of the same. Suppose first we have graph between P and T. Okay, so graph between P and T would be a straight line where constant would be NR by V. Okay, if we talk about graph between P and 1 by T, so graph between P and 1 by T would be, as P and 1 by T would be inversely proportional, hence it would be something like this. And what about the graph between P by T and P or T? So we know that P equals to KT, or P by T equals is constant value, hence using the same, P by T is a constant value, and it doesn't matter what is on the x-axis, whether it is pressure or temperature. Okay, now let's discuss another important law, which is Avogadro law. Avogadro's law. So this tells that volume is directly proportional to number of moles of the gas. Okay, and combined gas law is nothing but PV by T is constant, or we can say that P1 by V1 divided by T1 should be equals to P2 V2 by T2. Okay, so this is the combined gas law, and we can also say that PV by T is directly proportional to N, or PV upon T is equals to Rn, or this implies PV equals to nRT. Okay, so next let's discuss Dalton's law or Dalton's law. So Dalton's law, this is Dalton's law of partial pressure. Okay, so Dalton's law states that suppose we have a vessel in which we have several gases in the same vessel. So what happens in this vessel is, suppose we have moles of A, B and C. So what will happen here is, suppose we have moles of A, B and C in this vessel. So what will happen here is, we have pressure, total pressure of the mixture would be partial pressure of A plus partial pressure of B. This is this is B and partial pressure of C. Okay, so this is the total pressure, and we can say that P total into volume of the vessel should be equals to N total into RT. Okay, so this is equation number 1. Okay, so now total pressure of a gaseous mixture is same as partial pressure of all gases present in the, rather it's not the same, it's the sum of all the partial pressures of all gases present in the mixture. So total pressure of gaseous mixture is sum of partial pressure of all gases present in vessel. Okay, so where we can write that N total is nothing but moles of A plus moles of B plus moles of C. this is N total. Okay, and we can write that we have already seen this, but I'm rewriting this, that partial pressure of any gas, so let's say for example of gas A would be equals to mole fraction of gas in the mixture multiplied with total pressure of the mixture. Okay, so this is how we define partial pressure of any gas in the mixture. Okay, now let's move on to another concept, which is collection of gas over volatile liquid. Collection of gas over volatile liquid. Okay, so suppose we have this vessel which actually contains H2OL. Okay, this contains H2OL, and obviously there would be vapor pressure of H2OL, which is H2OG, would be present, and let's say we also have some dry air present in the mixture. So first let's write that pressure of wet air would be equals to pressure of dry air plus vapor pressure of H2OL. We have discussed the vapor pressure in some previous lectures, vapor pressure of H2OL. Okay, so we can write that P of wet air is equals to P of dry air plus H2OL. Okay, dry air plus P of H2OL. P of H2OL is nothing but vapor pressure. Okay, so we are assuming that the vessel initially contains some dry air, and now it will also contain the vapor pressure of H2OL. Hence we wrote that the total pressure of wet air will be pressure of dry air, which was initially present, plus pressure of or rather vapor pressure of H2OL. Okay, and we have also discussed the concept of relative density, relative humidity rather. So we know that relative humidity is nothing but partial pressure of H2OG divided by vapor pressure of H2OL. Okay, and multiplied by 100 will give you the percentage. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on calculation of partial pressure of a volatile, partial pressure of a gas over a volatile liquid, or we'll be continuing on seeing more on the same in the next lecture as well. So till then, good luck and goodbye.